Hello, and welcome to what is going to be the last episode of this series on trigonometry. So I'll be going through the sum and product formulas today. And there's not going to be too much to this episode. I'm just kind of going to list them out as well as try to give some intuition on why they are true. So sum and product formula is, um, well, it's kind of a way to switch between the sum of coses and sines to the product of coses and sines, if for whatever reason you need to do that, which is actually pretty fairly common in math contests. Okay, so let's start with the product side of things. So let's say you had like cos of alpha times cos of beta, and you wanted to turn this into like either a sine or cos of some angle plus, or minus the sine or cos of another angle, right? And then of course, you would also have cos of alpha, sine of beta. So if there's one of each, and then also sine alpha, sine beta. Okay. So what we would do here is, okay. So for this cos of alpha, cos of beta thing, what we really need is we need some way to actually generate this cos term. We know that for a sine, right, for sine alpha plus beta, we're going to have a sine alpha cos beta plus a sine beta cos alpha. So the sines, like if we try to use a sine here, most likely what we're going to get is we're going to get a sine times a cos. And that's not going to cut it because we need a cos times a cos. And so this is why we're going to be using cos. So for cos of alpha plus beta, we're going to get cos of alpha cos of beta minus sine alpha sine beta. And of course, we also need the opposite then, because we want to cancel out this term. We don't really want it. So we're going to take, we're going to take cos of alpha minus beta this time. And so we're going to get cos of alpha cos of beta plus sine alpha sine beta. And what that's going to do for us is after we add these two, we can now effectively cancel out the sine part of it, and we're left with just a cos alpha cos beta. So we can say that cos of alpha plus beta plus cos of alpha minus beta would be equal to 2 cos alpha cos beta. And now if we divide both sides by 2, what we can do is here we have a way to switch between a product and a sum. And so you can imagine a pretty similar thing for sine of alpha, sine beta. So looking at these two equations, this time instead of adding the two equations that we have here, so let's label them say 1 and 2, we're going to subtract them. So let's do 2 minus 1. And so what this does is this gives us the second equation minus the first equation. So the coses are going to cancel, and we're going to get 2 sine on the right side. So then on the left side, we're going to have cos of alpha minus beta minus cos of alpha plus beta. And then here, similarly, we can divide by 2. And here we have a way to switch between a product and a sum or a difference in this case. Okay, now for the final one, if we're trying to find a way to switch from sine of alpha cos of beta to some sort of a sum. Okay, so here we have to take a look at the sine formula. So let's just write it out. Okay. Here we go. And just like previously, we're going to write out the difference. And now to get a sine alpha cos beta, what we're going to see is we're going to have to add it. So if we add these two equations, we will get that sine of alpha plus beta plus sine of alpha minus beta would be equal to 2 sine alpha cos beta, since the other one cancels out. Then we divide by 2. Great. So now we can go from a product to a sum. Okay, so now let's look at how we can go the other way. So to go from a sum to some sort of a product. So let's say we have a cos of an angle. So let's say we have cos alpha plus cos beta. The other cases are a cos plus a sine, so we can say something like this. And then, of course, a sine plus a sine. So one thing we may have noticed is that to effectively cancel out, we kind of need a cos with a cos. So what I mean is, so for example, in the first one, when we were finding the product into the sums, we had to do the cos of alpha plus beta and the cos of alpha minus beta, and somehow combine these two formulas to get what we want. And the reason why is because the cos expansion formula will give us a cos and a sine, but the sine expansion formula will give us a cosine and a sine cos. So this is actually not a great way to combine this cos and sine here, so we're just not going to look at it for now. And if you want to do some sort of manipulation, the best way to try to do it is to turn the sine beta into a cos of 90 minus beta. And then, or the other way around, right? You can turn the cos alpha into a sine of 90 minus alpha, but either way, there just isn't a great way to do that. So now let's take a look at how we can cancel out the cos and the sine. Okay. And so a lot of this is just going to be reverse engineering what we saw, right? Okay, so let's take a look at the sine. So where have we seen the sine so far? Well, it's over here, right? Where we found the, when we went from sine as a product to sine plus a sine. So now we want to somehow have these two variables act like this sum and this difference here. Okay. So let's actually just say, no, let's replace these two variables with, say, x and y. So we want to say x plus y is the first angle, so let's say alpha, and x minus y is the second angle, so let's say beta. Okay, and we know then sine of x plus y, so sine of alpha plus sine of beta is going to give us the 2 sine x sine y, which is just this product formula but reversed, kind of. So now to solve for x and y, well, this is pretty straightforward. So we're just going to add these two equations and we're going to get 2x is equal to alpha plus beta. And so x would be alpha plus beta over 2. And so y would be equal to, after we sub it into one of the equations, we would get alpha minus beta over 2. So if we want to rewrite this formulas with the new x and y that we have here, we can write them like this. And now for the final one, which is a cos plus a cos, again, we really want to use the cos formula that we saw. So the cos formula that we saw up here, I'm just going to use the addition case. Again, it's a very similar idea. We had the alpha plus beta and the alpha minus beta. So you can actually just copy exactly what we had. So, you can say cos of alpha plus cos of beta would be equal to 2 sine x sine y. Oh, sorry, not sine, cos. 2 cos x cos y. And so this is literally just the exact, just taking this formula and kind of turning it on its head. We're replacing the alphas here with the x and the betas here with the y as before, and we're saying x plus y is alpha. So x plus y is the first angle and x minus y is the second angle, which is what we did over here. So again, it's actually the exact same thing as we just did. In fact, the two equations that you're going to get are still the exact same. So we can say that this will be 2 times cos of alpha plus beta over 2, cos of alpha minus beta over 2. And that's it. So that's it for this episode, and that concludes the trigonometry series. It's been a really cool journey. I know this episode took a little bit while to come through. I've been a little bit busy, but I really hope to do a lot more of these things in the future, and hopefully with kind of a better system as well. So this is obviously my first series, and I'm just always looking for steps to improve. So with that, I'll see you in the next series.